All right, new topic called marginals. We have 3 definitions to look at, and gratefully when I know one definition, I pretty much know the other 2. So let's take a look. Marginal cost. The marginal cost at x, and that is given by the first derivative of the cost function, is the approximate cost of the x plus first item. And the derivative would be found by taking the cost of the x plus first item minus the actual cost of x. Okay? By the way, this can be rearranged. Since it is an equation, you can rearrange it and say the cost of the x plus first item is going to be found by taking the first derivative of the cost function and adding the cost to it. So you can always rearrange these equations if you need to. But let's just understand what they're trying to tell us. This marginal cost is talking about the approximate cost of the x plus first item, which is why I took their original equation and rearranged it so it said the x plus first item. Cool? Okay. The other 2 are basically going to read the same. I have the marginal revenue, and the marginal revenue at x, and that is given by the first derivative, is the approximate revenue of the x plus first item. Now again, if it's supposed to be the x plus first item, my brain wants to rearrange this equation and say the revenue of the x plus first item is equal to the first derivative at x added to the original revenue function. Marginal profit, same thing. It's the approximate profit of that x plus first item. So again, my brain is like, hey, well, let's rearrange it to the profit of the x plus first item is going to be the derivative of the original function, profit function, added to the profit function. Cool? Okay, so stay tuned. Got some examples. All right, did you read that first story? Let's take a look at it again. Let R of x and C of x be, respectively, the revenue and the cost, and P of x, sorry about that, and P of x be the profit. And x is the number of items that have been produced and sold. R of x is this function, C of x is this function. And then they give me, what, 4 parts? All right, so let's take a look. So first off, in part A, they want to know P of x. They want to know the profit, don't they? Okay. By the way, besides writing down the 2 functions, I also wrote down what the variables represent, which is also very important. Okay, so first things first, they want the profit function. Got it. So we need to find P of x. And how do you find profit again? Yeah, that's correct. Revenue minus cost. And we have done that before, haven't we? Okay, so we're going to take the revenue function of 5x minus the cost function. Please put the cost function in parentheses. Why? Because you know you're not just minusing one of those terms, you're minusing all 3 of those terms in the cost function. So 0.004x squared plus 1.7x plus 60, that's all getting subtracted off. And after you distribute the minus sign and collect like terms, this is what I got. I got negative 0.004x squared let's see, plus 3.3x and then minus 60. Did you get the same thing? Good. All right, part A, check. Part B. So part B wants you to find the revenue, the cost, and the profit at 200. All right, so part B. They want you to find the revenue at 200, the cost at 200, and then the profit at 200. So what do you think you're going to do to answer all 3 of these questions? You're going to plug them in. Where are you plugging them in? Yeah, R of 200, you're plugging into the revenue function, right? So I got 1,000, did you? C of 200, the cost at 200 items, because that's what that represents. I got 560. Did you? Good. And then the profit at 200 items. Remember, this is our profit function. What'd you get? Good. I got the same thing, 440. Now, before we move on to part C, let's make sure part B makes sense. So revenue, cost, and profit are all in dollars. Agreed? So my revenue is $1,000, isn't it? My cost is $560. My profit is $440. Remember what we said in part A? To find the profit, you're going to take the revenue, subtract the cost. Well, if the revenue at 200 items is $1,000 and the cost is at 200 items is $560 and I subtract the two, I better get $440, shouldn't I? Which is what I got when I plugged this 200 into my profit function. So yay, good check. Cool? All right. Part C wants us to find the first derivative of each of these three functions. So I need the first derivative of the revenue function. If the revenue function is 5x, what's its first derivative? Good, 5. I need the first derivative at the cost function. So my cost function was that second degree equation. What did you guys get? Good. I heard you, 0.008x plus 1.7. Agreed? Love it. I got the same thing. And the first derivative of the profit function. Here's my profit function. Yep, it's that second degree equation again. So negative 0.008x plus 3.3. Good? All right. Last but not least, part D is asking you to now find the first derivative of each one of these functions at 200. So, where are you going to plug the 200 into this time? Correct, into each of these particular first derivatives. So the revenue at 500 is still just going to be 5. Or the first derivative of the revenue function at 200 is still going to be 5, correct? Okay. The cost at the first derivative, plug in the 200. What'd you get? Yep, I got the same thing, 3.3. And the profit, first derivative. Yeah, I got 1.7. Now, here's what this means. You're like, what the heck does this mean? The revenue, right, the first derivative at 200 means this is, the revenue is $5 per unit at the x plus first item. Because remember, the first derivative based upon the previous definitions was for the x plus first item, right? Okay. Or pardon me, of the x item. My goof. Good? Okay, the cost is $3.30 per item at 200 items, and the profit is $1.70 per item or unit at the 200th. Cool? Okay, this was a good one to start with. It kind of gave you an idea of doing this double check here, understanding what these derivatives are telling you. Got it? All right, I'll be right back with another story, so hang in. All right, let's take a look at the next story. It says, suppose that the monthly cost in dollars of producing X chairs is given by this cost function. And currently, 25 chairs are produced monthly. So they give us a third degree cost function. They told us X represents the number of chairs. Again, they've got 4 parts, so let's go through them and let's see what they're asking us for. So part A wants to know the current monthly cost. All right, so the current monthly cost. There's my cost function. So what did they tell us that they're doing monthly? Because X represents the number of chairs. Yeah, they're currently producing 25 chairs per month, aren't they? So to find the current monthly cost, you're going to plug 25 into that third degree polynomial that they gave you. All right, take a moment or two, figure it out. What'd you get? Lovely. I got the same thing, $1,196.88. Cool. Good. All right, that one's pretty straightforward. Part B, they want to know the marginal cost when x equals 25. So, remember the definition just a few minutes ago. Marginal cost. We have to, yes, we have to find our first derivative, don't we? So, find the first derivative of the cost function. So, what are you getting? Yep, 0.015x squared plus 0.14x plus 19. Good. There is your first derivative. But they didn't just ask for the marginal cost. They wanted the marginal cost when x equal 25. So now that you found the marginal cost, which is the first derivative, you're going to find it specifically at that 25 chairs. Okay, so take a few moments, plug in your 25, see what you get. Good. What'd you get? I got the same thing. I got $31.88 per chair. That's my marginal cost. Okay. Now, part C is interesting. Part C says use the result from part B to estimate the monthly cost of increasing production to 27 chairs per month. Okay, so now let's think about this. The marginal cost at 25 chairs is $31.88. That's basically the cost per chair. Part C says, well, what happened at 27 chairs? What would be your monthly cost at 27 chairs? This is what it's asking for. It didn't ask for the marginal cost. It's asking for the cost at 27 chairs. So now let's think about it. If I knew the cost of 25 chairs, which we do, don't we? And I was able to add to it the cost per chair, and I'd have to add that twice, wouldn't I? Because this would be chair 26, this would be chair 27. Wouldn't that give me the cost of 27 chairs? So then, couldn't I write this as the cost of 27 chairs would equal the cost of 25 chairs plus 2 times the marginal cost at 25 chairs, because that's what it is. The cost per chair was $31.88. Agreed? Okay, which means our cost at 25 chairs was $1,196.88. And if I add to it 2 times the $31.88, I'm going to write it over here because I'm going to need board space for part D. What would you get? Okay, I got the same thing. $1,260.64. Good. Does that make sense? Yeah. If my cost per chair is $31.88, then all I got to do is keep adding that marginal cost onto it. Onto like the 25 chairs. Cool? Okay. Now, part D says, well, wait a minute. What would be the actual additional monthly cost of increasing production to 27 chairs? They want the actual monthly cost of increasing to 27 chairs. Well, if I knew the cost at 27 chairs, I could answer that question, couldn't I? So check it out. The cost at 27 chairs plug it into the original function, this third degree polynomial. I'll wait a few moments. You tell me what you get. Good. I got the same thing. I got $1,262.45. Our estimate based on part B was $1,260.64, correct? Which means we basically have between part D and C, when I subtract these two numbers, I actually have an increase of $1.81 in production. Not bad, right? My marginal cost was just almost close enough. Just there, almost. $1.81 off. Not bad. Good? Okay, got another one. Hang in there. Did you read that third problem? Okay, so we're dealing with a computing company, right? And it finds that its weekly profit in dollars is given by this particular function of X laptops sold. So X represents the number of laptops. And they want to, or they tell us that the currently the company builds 11 laptops weekly. Good? Okay. So we have 11 laptops being built weekly. We have our profit function here, and we know X is the number of laptops. So, once again, 4 parts. Let's go to it. Let's see what part A wants. Part A wants to know the current weekly profit. So how are you going to figure out part A? Yeah, you're going to find the profit at 11 laptops. All right, so get those calculators out, get figuring. I already did mine. Let's see if we agree. All right, sounds like we did. I got $6,787.17. Wonderful. Cool? All right. So let's get to part B. What does part B want to know? How much profit would be lost if production sales dropped to 10 laptops weekly? So what do you think you're going to have to do? Yeah, you're going to have to find the production at 10 laptops. So you guys figure that out. I've already done my work. Let's see if we agree. You got it? Okay. I got $6,070 with 10 laptops, which means if it dropped from 11 to 10, what do we got? Yeah, we have $697.17 drop, don't we? Cool? All right. Let's see. What does part C want to know? They want the marginal profit at 11 laptops. All right. So marginal profit means what? Find the first derivative of the profit function. We got to do that first. So you do yours, I'll do mine. I already did mine. Pause the video if you need to. Okay, got it? All right, let's see if we agree. I got negative 0.018x squared minus 0.8x plus 700. But they want the marginal cost at 11 laptops, or marginal profit at 11 laptops. Yep, which means now you plug the 11 in to the first derivative. So go ahead and do it, and I'll do mine. What'd you get? Good. I got the same thing. $689.02. Agreed? Okay. So, interestingly enough, right, the marginal profit said, or the marginal profit definition is the marginal profit of X given by the first derivative is the approximate profit to the X plus first item. So, this means is this would be the profit of the X plus first item, which is close to here, isn't it? The marginal profit at 11 was almost the same as the difference between the profit at 10 laptops and the profit at 11 laptops, wasn't it? Okay, one more part. Part D, what do they want to know? Use the answer from part A and part C to estimate the profit from production of 12 laptops. Okay, so if this is the profit at 11 and this is the marginal profit at 11, what do you think you're going to do to find the profit at 12? Yeah, I heard you. You're going to add them together. You're going to take the profit at 11 and add it to the marginal profit at 11. Does that make sense? And by the way, that was the rearrangement. Go back to the notes. Hopefully you wrote them down. This was the rearrangement that I wrote down of the marginal profit equation that they gave us. They gave us this equation, and then I rearranged it to get the profit at X plus 1 by itself, which would have been the profit at X plus the marginal profit at X, which is exactly what we're doing here. Cool? Okay, so we're going to take the $6,787.17, add to it that marginal profit at the same amount of laptops, 11, and what do you get? Good. $7,476.19. That's what you get. Good? Okay, stay tuned. One more. All right, let's look at that last problem. It says the average cost for a company to produce X units of a product is given by this particular function. They would like us to find the first derivative of this particular function, which is the average cost, find the first derivative to estimate the change in the average cost as the production goes from 150 units to 151 units. Okay. So one thing I forgot to write down here is X actually represents the number of units. So the first thing they said was find the first derivative. Agreed? Okay. So you have to remember how to find the first derivative of a quotient, because that's 20x plus 900 all over x. So first things first, find the first derivative. You remember how? Good. Take the derivative of the numerator, would just be 20, multiply it by the denominator, subtract from it the numerator itself, 20x plus 900, multiplied by the derivative of the denominator, which would just be 1, all over the denominator squared. Okay, so gratefully, this one isn't too bad, as we need to simplify. So we have 20x minus 900 over x squared. So it looks like our first derivative for the average cost is going to be a negative 900 over x squared. Do you agree? Okay. Now, they asked us to use the first derivative to estimate the change. And by the way, when you're doing that change, that is the first derivative, right? In average cost, as production goes from 150 units to 151 units. Okay, so to find the average change as it goes from 150 units to 151 units, I need to find the average change at the original number of units, the 150 units. I need to find that. So we have negative 900 over 150 squared. Okay, They're talking about money, so you're going to round to how many decimal places? 2. Good. What'd you guys get? Look, I got a yeah, you do get a negative number. Negative 0.04, basically cents, right? Let me stick in my dollar sign here. There we go. So a negative 4 cents, right, per unit. That is the average change to go from 150 to 151 units. Now I'm going to do a double check for you. Why? Because I need you to see what actually happened here. So we're going to do a check. And here's the check. I want to find, using the original function, remember the original function represents the average cost. The first derivative is the change in the average cost. I want to do a check. I want to see if this negative 4 cents per unit is right. So help me out. What is the average cost at 150 units? And then what is the average cost at 151 units? Remember, I said average cost. I didn't say the change in it. I just said the average cost. You guys go figure these two out. And remember, I'm talking money, aren't I? So yeah, round to 2 decimal places. I shouldn't have to tell you that. So what do you get as the average cost at 150 units? Good. I got the same thing. I got $26. What did you get at as the average cost of 151 units? Yeah, $25.96. So to go from 150 to 151 units, it did, didn't it? It dropped by 4 cents per unit, didn't it? Which is exactly what we got over here when we found the change in the average cost. And by the way, you always start with the original amount because you're looking at what happened at 150 to 151. So when we did the change in the average cost, we're going to evaluate it at the original number of units, which was 151. Good? Okay. Hopefully this made sense, doing our check and making certain that these agreed. Hopefully this made sense to you. I hope you have fun with this section, and I'll catch you.